Hey everybody, welcome to the Data Lab lecture. So let's just get right to it. We're going to jump right in. We're just going to talk about how to record data. The first thing you should know is a very important part of science relies on the ability of scientists to reproduce their results. This is required that scientists maintain complete and accurate records of their work. And this is why lab notebooks have such specific guidelines and why it's so important for anyone in the science field to learn proper techniques in recording data. This is going to include every piece of data with every single unit, sketches of lab equipment used, observations during your experiments. Now, if you have where it says sketches, we're talking about a traditional lab notebook, a composition book, pen and pencil, but that's not what we're doing. What we're doing is we're working with digital lab notebook. And so with the digital lab notebook, my advice to you would be if you're reading the lab and you don't know what a piece of equipment looks like, you should pop over and grab a screenshot of a picture or something like that and put it in your procedure tab. That'll have, a great impact on you being in lab and being able to know exactly what you're looking for. I'm always available to answer questions, but sometimes it's nice to have a picture like that. So, every instructor that you have may or may not require a different set of rules regarding your lab notebook. So you guys know what the rules are for this class. Others are going to require that you submit a lab report over keeping a lab notebook. And basically, it's at the instructor's discretion. So we're trying something a little bit different. We're going to keep the digital lab notebook in this class. All right. So let's talk about how we're going to record observations. Make sure you record what you see initially and every change that occurs. What you see initially and everything that changes as the experiment continues. Especially of importance are chemical changes like colors or formations of a gas or solid. You're going to need to record notes about your progress and whether you've made any modifications to the experiment. It's okay if your experiment doesn't work. That's the beauty of science, but you're going to need to notate that in your lab notebook. Consider your observations to be notes that you're taking during your experiment. So notes that are going to be useful in repeating or understanding your experiment. The idea is that if I come over and borrow your lab notebook, I can repeat the steps that you did and I can get really close to the exact same outcome that you had. So that's the point of that. So let's just talk about signing and dating your data. At the end of every lab, you're going to be asked to sign and date your data sheets. All right. All this is it just verifies the experiment was carried out and that you're the one who did it. Your signature basically is your word that the data you're presenting or that you have, they were obtained in an honest fashion and to the best of your ability. And as a science, you are now held accountable for the data and conclusions that you communicate to others. Now, data handling, graphing, and density determinations, you guys, this probably isn't new hat to you, but we're going to get through it. So one way that scientists have of organizing and understanding data that they collect is a graph. They graph the results, and a graph is nothing more than a visual representation of the relationship between two variables. It could be any two variables, right? It gives us the ability to quickly see and understand the relationship between two measured values. Now, some relationships are going to be linear, which means that the line is straight when your result is plotted, very similar to this. Other relationships are going to be non-linear, and those are going to result in curves like you see here. Graphs are drawn on axes, two straight lines drawn at right angles to one another, and the vertical line is the y-axis. The horizontal line is the x-axis, okay? So your vertical line is the y, and your x is going to be horizontal. Your axes usually cross at your 0, 0 origin, but that is not always the case. If you see something different, that happens sometimes, but typically it's going to be crossed at 0, 0. Now, when you're constructing your graph, it is customary to plot the independent variable or the quantity under the control of the person. The independent variable is what someone can change, right? You're going to plot that along your x-axis. Your dependent variable depends on the changes of the independent variable. It's going to be plotted along the y-axis. So sometimes the assignment of quantities to these axes are arbitrary, but this is how we're going to approach it for this class. When the results of your experiment form a straight line, a mathematical relationship, or some people might call it an equation, exists between the variables plotted. So one way that this relationship can be expressed is called slope-intercepts form of the equation of your line. Okay, slope-intercepts form of the equation of your line. The slope of a straight line, which is represented by your lowercase m, that's your slope, it is basically the ratio of the rate of change in y to the rate of change in x, okay? And you can see here, obviously, I misspelled the word straight. I'll have to go back and fix that. But you guys know me by now. I'm not stopping this video to fix that. I will get it fixed for next time. So let's just show you what I'm talking about. In order to find the slope of a line from your plotted data points, you're going to have to first find the data points using your rules and in your outline in your section, General Information and Construction of a Graph. You're going to find that in your handout, and you can follow those rules. Make sure you're following those rules. Choose 2 points that are not actual data points, but they fall on the best best straight line that is plotted. Okay, so they're not data points, but they fall on the line. If it's possible, you're going to choose 2 points that lie on the grid of the graph paper that are pretty far apart. Sometimes you won't have that luxury, but that's the goal. Now, why do we do this? We do this to make it easier to read the values off of the x and y axes. Now, you're going to show these selected points by drawing a dashed triangle just like the one that you see here. Okay, those are your points. It's a dashed triangle. Those are your points on your line that aren't data points. So if you're looking at this graph, your data points are the light blue squares that go along the line. And so we've chosen 2 points right here, x1, y1, and x2, y2, that are on the line but are not on the graph, and we've drawn our triangle for that. So let's talk about density. Density is the ratio of mass per unit volume. That means density equals mass over volume. That's all that means. Now, this definition is going to be similar to the definition of the slope of the total mass of a substance that's plotted on the y-axis and the total volume of substance that's on the x-axis. The density of the substance is given by the slope of the best straight line through the data points. Okay, that's how you're going to come up with the density. Now, in this particular experiment that we're going to be doing this week, what you're going to be doing is you're going to investigate the relationship between the mass and the volume of about 30 pennies, and you're going to construct a hand graph. You do not need to bring graph paper. I will give you graph paper. This is the only hand graph that you have to draw in this class. There is no reason to go spend money on graph paper. Graph paper is expensive. I will make sure you have a piece before you leave your class. If for some reason you're ready to go and you do not have graph paper, make sure that you reach out to me before you walk out the door so you don't have to spend that money. So after you do that, you're going to investigate the relationship between the mass and the volume of an unknown liquid using a spreadsheet program. Now, I have instructions in the lab for Excel. If that doesn't work for you, use any spreadsheet software that is good for you. I'm indifferent by it. Just know that you will have to turn it in with your lab report, and it is not a screenshot you'll be turning in. You'll need to print it out and scan it into one PDF with your lab report. And I also want to remind you to leave room in your notebooks to add your graphs inside of your lab report. So you're going to scan, you're going to have to, however you decide to do it, it just needs to be scanned with your lab report into one PDF document. All right, that's going to be it for the data lab. Data is straightforward. It's a lot of fun. Just make sure you're signing your stuff and follow the rules when you're making your graph. If you have any questions, make sure to reach out, and good luck.